Okay, I had a request for number 19 and 22 to work out. For number 19, you're supposed to be graphing a polynomial. Polynomials are supposed to be smooth, continuous curves. So we're really looking for when is this thing up and down or above or below the x-axis, essentially. One way to figure that out is to first of all factor the polynomial and see if it has any x-intercepts. So here's our polynomial. Since there are 4 terms, I'm going to try to factor by grouping. I can pull an x squared out of the first pair and a -4 out of the second pair. That makes this x plus 2 times x squared minus 4, which does factor again into x plus 2 for this guy, and then the x squared minus 4 also makes an x plus 2, but also an x minus 2. So it looks like this factors into x plus 2 squared times x minus 2. Now, that gives us at least our starting point for how we would graph this, because the next thing we want to do is find out where are those x-intercepts. X-intercepts are anything that make the factors equal 0. So it'd be -2 and 2. So we can go ahead and place a dot on -2 and +2 on our graph. Now, to be able to know if this graph is going down, up, or down and up, whichever it is on each side, we can make a little table chart on the number line. Put from least to greatest. Pick a test value in each region, so -3, 0, and +3. And then you want to plug this into all of the factors. So I actually usually plug it into this case because it's easier to plug in. So x plus 2, x plus 2, and x minus 2. And we're going to do this for all the test values, and we're going to see what does it come out to. So -3 plus 2 is negative, -3 plus 2 is negative, -3 minus 2 is negative. So 3 negatives make an overall negative. That means that is below the x-axis on this side. So if this is my point for -2, I'm down right there. When I plug in 0, I get 0 plus 2 is positive, 0 plus 2 is positive, 0 minus 2 is negative. This is also negative overall, which means this is also below. That means on the right side of this point, we go down again, some unknown amount, until we start heading towards this last point. 3 plus 2 is positive, 3 plus 2 is positive, 3 minus 2 is also positive. That's 3 positives, which means we cross the x-axis and go above. So this is the graph of number 19. Oh, and we have one more piece to talk about. There'll be a little blank on the test for these. It'll say f of x is greater than 0, and it'll have a blank, and f of x is less than 0, and it'll have a blank. The less than 0 ones, remember, are your below answers. The greater than 0 are the above, so it's just interval notation. So -infinity to -2, that's this region. Unioned with -2 to 2, those were both below or less than 0. And the only one above was +2 to infinity. Okay, number 22 is graphing a rational function. This is when we care about things like vertical asymptotes, x-intercepts, holes, horizontal asymptotes, or oblique, because we don't know which one yet, and then y-intercepts. To find the vertical asymptote, first of all, you have to make sure your polynomial is completely factored. This one is. There's nothing to do to this binomial, and you can't reduce the 4 and the 6 because one's a monomial and one's a binomial. So anything that's left in the denominator after reducing is a vertical asymptote. So if we set x minus 6 equal to 0, we get x equals 6. X-intercepts means you have to have an x on top. So since there are none, there are no x-intercepts. Holes only happen if something cancels out, and we won't have any on this test because this is the only example you have, so there are no holes. We'll come back to the horizontal versus oblique. A y-intercept means you plug in 0 for all the x's, so that's 4 over -6, which is -2/3, and that's a y-intercept. And to know if you have a horizontal or oblique, because you can't have both at the same time, you have to check whether or not you can do long division. If you cannot do long division at all, it's 0 and it's horizontal. if the thing you have on top matches the thing you have on bottom in terms of like they both have x to the first power, then it would just be 4 over 1. It would be the coefficients. And obliques only happen when the top is bigger degree than the bottom. So since this is the case where x can't go into 4, that means it's a horizontal asymptote at 0, and which means we have no obliques. Okay, so you needed all this just to get started. So this is 1, 2, 3, 4, 5, 6. We have a vertical asymptote there at positive 6. Our horizontal asymptote is at y equals 0. We have a y-intercept at 0, negative 2/3. That's down here. And we have no other points. So what we'd probably want to do is we'd probably want to make a table of values and get some more values up here. Maybe some things closer to this line, maybe on the other side of this vertical line. So maybe I'll plug in positive 2 and positive 4 because those are both on the left side, or the left side of this vertical asymptote. And maybe I'll plug in 7 and 8 for 2 points on the right side. So we just plug them into our equation. So 4 over 2 minus 6 is 4 over negative 4, which is negative 1. So I have the point 2, negative 1. And 4 over 4 minus 6 would be 4 over 2, negative 2. So that guy's negative 2. So here's 4 and then down 2. Notice that this graph looks like it's hovering on this asymptote and then going towards the vertical asymptote and headed down. So there's that portion of that graph. This is only this side of the vertical asymptote. There should still be graph on the other side. So that's what we're going to find out when we plug in the 7 and the 8. So 4 minus 6 is 1. So that would just be 4 over 1, which is 4. So positive 7 and then up 4. And if we plug in 8, that becomes 4 over 2, which is 2. Which is right there. So notice this one's starting up high and headed down towards that bottom asymptote right there, the horizontal one. So that is the graph of number 12, or 22, sorry. And I will see you guys tomorrow for the exam.